Okay, welcome to Lesson 2, Adding by Components. Now in this lesson, we're going to be building off of the skills in the last one, and we're actually going to be determining the x and y components that make up our total vector line, I guess is what we could call it. It's easiest just to jump right into the example. So for example number 1 here, this is asking us to determine the x and y components of the vector v, where v is equal to 240 meters at 30 degrees west of south. All right, so the first step in any of these problems that you're going to want to be working through is we want to sketch a grid first off. If you don't have graph paper, you'll just sketch a simple grid into your blank and determine where on this grid our line is moving. In this case, it's going to be 30 degrees west of south. So starting at south, moving towards the west, we can show that this line is probably going to move out here somewhere. All right, that's about 30 degrees, I'd say, just eyeballing it. There we go. There's our line. Two things we want to label on here. First is we want to label that this angle is our 30 degrees. And also, it's probably not a bad idea to label this side length as 240 meters, right? That's this side length that it's attached to. Okay. Now what's the question asking for? Determine the x and y components for this vector. Well, this is our vector. You can put even a little arrow on the tip of it here. And we want to determine, well, if you're just moving in straight lines, right? If you can only move in x direction, right, left or right, and you can only move in y direction as your other option, up and down, how would you move to get to that spot if you started at the origin? Okay, well, the way we would get there is we would probably move down and to the left, or to the left and then down. Either triangle will work. We're just going to be solving for a different angle, but both are acceptable. I'm going to be doing the down and to the left method. Okay, so down this way, you can trace down a line, and this is our y component. So we're going to have to figure out what that is equal to. Also, as we move across, maybe I'll do the across in blue, our x component. So we're moving this way. So our x component is equal to something. Okay, so it's set up. Now all I have to do is a little bit of trigonometry, and we should have this done. First one I'm going to solve for, since I have my blue marker out already, I'm going to solve for the x value, this one across here. Remember, you can also measure it along here if you like to, like across and then down, whatever floats your boat. Okay, so I'm going to say that this x vector x is equal to, well, we have to know our trigonometry laws here. So it's this side length, and we have a hypotenuse, and we have this unknown length. This is the opposite. So we have opposite and hypotenuse. Opposite and hypotenuse gives me the sine rule. Remember, SOHCHTOA. So we have opposite and hypotenuse. Sine of our angle, 30, is equal to, well, opposite over hypotenuse. So our x over 240 meters. We can just cross multiply this up, or multiply both sides, right, by 240. And we should end up getting our Vx equal to sine 30 times 240 works out to 120 meters. So we just solved this x component, and we now know that that is equal to 120 meters. Okay, let's do the y component. So vector y is equal to, we now have the adjacent side length, and we have the hypotenuse. Try not to use your solved lengths in your calculations when you're solving for a second calculation, just because any decimal loss in this, despite this one being an exact value, any decimal loss will slowly over time build up and make your answers less accurate. So if we were doing, I don't know, it's not going to make a huge difference, but 10 of these calculations in a row, after a while we're going to lose a little bit of accuracy in our answer. So try to only use the given values in your calculations. So here we're going to have cosine of 30 is equal to our adjacent, which is what we're looking for. So I'm going to call this one y over 240 meters, which is our hypotenuse. So I have vector y coming out to equal, I'll get 207.8 meters. With sig digs, this thing gives us, we start with 240. So let's call this 208 meters. Okay, those are actually our final answers, right? We've got x and we've got y, so I'm going to put a box around each of those. Let's do this, and let's do that. That's it. I hope that was clear enough for you.